Hello, I am Sara Caballero Bruno, and this is a presentation about my master's project, Learning to Control Efficient 3D Procedural Noise from Exemplars. This project is based on a previously published paper. They developed a machine learning model that takes a 2D input texture and can predict the appropriate 3D texture space. A 3D texture space would be a dynamic texturing algorithm for any 3D point in space. There are two main goals of this project. Firstly, is to serve as a demonstration of the original concept. In other words, to create a real-time rendering environment where we can show the dynamic texturing on some 3D objects. Secondly, is to optimize the original model. The original model was too complex to actually work in a rendering environment, and therefore we need to create a simpler, faster model. What is the motivation for this project? Apart from the already mentioned goals, the main motivation of this project is all the possible applications that it could have in modeling, graphics, simulations, or even gaming. How was this project done? Firstly, we need to establish our dynamic texturing algorithm, Perlin texture. Perlin texture or noise is a commonly used dynamic texturing algorithm for stochastic textures. It follows a three-step algorithm which divides the space into a grid, finds the nearest noise, and then interpolates. So, there are two main stages of our project: synthesis and analysis. For the synthesis stage, we designed a rendering environment that can showcase the dynamic texturing. This rendering scene was created using WebGL, and it's a fully ray-traced scene. This invisible plane allows us to really visualize the benefits of dynamic texturing. We also have input fields to control the camera perspective. We also had to design the appropriate parameters to define a Perlin texture. We used Perlin grid mode to really visualize the effects of the transformation parameters, which are pretty standard, we can see. There are 4 modes of this project: the interpolation of the grid and texture examples: marble, grass, we can turn the reflection off, and wood. There is a custom mode where we can control the RGB Perlin parameters. The weight allows us to see the overall color, so the colors will be changed appropriately. The brightness determines the minimum color for the texture, or in other words, the darkest color that we can see in the dark spots from the shade. This allows us for an affine transformation of Perlin noise. For the last input field, the file upload, we first need to talk about the second stage of our project. For analysis, we focus on creating a model that can take an input texture image and output the Perlin parameters, which are the same ones that we described in the synthesis stage. This was a long, complicated process of trying many different designs. But in the end, the best model proved to be a 9 deep layer convolutional neural network that was divided in 3 heads for the 3 different types of Perlin parameters. Finally, we can see our results. With the help of onyx.js, we could embed our model in a rendering environment. Now the user can select any input texture image. The model will find the closest Perlin texture. Here we can see different examples for grass, marble, wood, and even a miscellaneous texture. When comparing our model to the previously published paper, we can see a visible loss of quality. This is due to the fact that our model is more simple, but also we have a single model for any texture instead of a specialized model for different texture types. However, this was a conscious decision we made in order to increase performance, where our model proves to be twice as fast and consumes 6.7% of the memory. In conclusion, a unified model was designed that can take as an input a texture image to predict a 3D texture. In the future, this model can be improved with more training, including a BGG to add details from the original texture image, and our rendering environment can be further used for other applications. Thank you for listening to this presentation. Have a nice day.